Welcome to Lesson 8. Today we're looking at the inverse of functions. This is part 1. Our learning goals for today include determining the inverse of a function algebraically and graphically, as well as determining the inverse of a rational and linear equation, and finally we want to be able to understand the relationship and determine the domain and range of a function and its inverse. Let's get started on today's lesson. Here in example 1, we're going to look at a function given by a set of ordered pairs and determine its inverse. So the inverse is just really interchanging the x and y values. So if we take a look here at the function we're given, if I want to now write the inverse of that function, I take each set of ordered pairs and I just rearrange their order. So instead of 1, 3, I'll have 3, 1. Instead of 2, 3, I have 3, 2. And instead of 2, 4, I have 4, 2. Close off my brackets, and now let me sketch to see what both the graph of f and f inverse looks like. So for f, I have 1, 3, so that brings me here. I have the point 2, 3, which brings me here. I have the point 2, 4, which brings me here. So clearly the f is a relation and not a function. As for, this goes away. As for the inverse, I'll do that with red points. I have 3, 1, so across 3, up 1. I have 3, 2, so across 3, up 2, and I have 4, 2. There you have it. So I'm not going to connect those points together. Let's look at the domain of the function. So the domain is just the first coordinates, so 1 and 2. So 1, 2. The range is the second coordinates. So in this case, I'm looking at 3. Well, we don't take repetitions, 3 and 4. 3, 4. There's my range. The inverse, it's just interchanged. So my domain of my original function becomes the range in my inverse. So I get 1, 2 here. And my range in the function, or relation, should I say, becomes the domain over here. Okay. So in terms of the graph, if I draw, I'm going to take a red point here, a line on a 45-degree angle through 0, what I get is kind of a visual representation of what the inverse looks like. It's a reflection in the line y equals x. Oops. Okay, in the line y equals x. In other words, I don't necessarily always have to determine the inverse from an equation or whatever. If I can just draw, say, the 45-degree angle line and just reflect the image I have in front of me, I have its inverse just by drawing a graph. We'll take a look at some more in example 2. So let's look at example 2. I have my function f. I'm going to draw my 45-degree angle line through the origin. There it is. And also going in the negative direction. And to reflect this, I'm just going to reflect some key points. Okay, distinguishable points. For example, this one here, I'll reflect in the line and it'll be over here. Notice that the point 4, 6 becomes 6, 4. The point 2, 4 becomes 4, 2. The point 0, 6 becomes 6, 0. And the point negative 5, negative 2 becomes negative 2 and negative 5. So what does my reflection look like? Well, this is where the artistic abilities of the student definitely come into play. Then we go here, then we go here. And that's it. You have a reflection in the line y equals x. Looking at the next one. Again, I'm going to draw in my line, 45-degree angle. And let me look at my key point here. So I notice I have -4, -4 and 3, so that becomes 3 and -4. So the point is down here. And anything else? Well, my y-intercept there is 0, 6, so that becomes 6, 0. And any other distinguishable point? Well, how about this one here? That looks like 8, 9, so that becomes 9, 8. So 9 and 8. Oh, it's 10. So 10 and 8. That'll bring me right here. And time to graph. So what is this going to look like? Well, is that right? Just draw this here. So that was -4 and 3. So 3, -4. Okay, well, I guess something like that. Maybe my curve isn't steep enough here. But you get the idea. There we go. Not the best drawing, but maybe with a bit of practice I can improve myself. Okay, next we're going to look at how to determine the inverse of a function from an equation, which is probably the main part of finding inverses. So we want to find now the inverse of a function algebraically. To do that, well, we have a 4-step process, and example 3 has that illustrated for you, which I'll let you take a look at the steps, make sure you understand them, and we'll use example 4 as a means to achieve this end. And we're using a linear function in this case. So step number 1 says rewrite the function in terms of y. So instead of g of x, I'm going to write this as y equals -2, x minus 4. Secondly, we interchange the x and y. So x equals -2, y minus 4. Step number 3, we solve in terms of y. So this is just a matter of isolating my y. Divide both sides by -2, cancel, cancel, and I'll rotate the order. I'm left with x plus 4 over -2. And step number 5 is, in this case it's not f, it's g. Rewrite my final function in terms of g of x, g inverse of x, which is x plus 4 over -2.